Good morning, boys and girls. Welcome back to the southern wing of the Stink Bug Works. Got several things I want to talk about today. First, let's talk about the concurrent build Big B and I are going to do. Now remember, and one of my viewers, who I shall call Jim, because in fact his name is Jim, mentioned it's going to be fun to see the difference between precision engineering and redneck engineering. And let me warn you, be careful of redneck engineers. You know, don't poo-poo these guys. These guys invented NASCAR, so even though it might be redneck engineering, there's some pretty fine points to observe there. Anyway, it is going to be fun because there's going to be two different approaches to similar projects. We're both waiting for parts, and I'm waiting for the red paint on the Ferrari to dry. I want to give it another day or so. Anyway, my next project is going to be a jet, and I'll put a link to it down in the description there. But my plan is this. The hull is small. It's 15, 16 inches. I'm going to give it, modest power. What am I looking at? I'm looking at a 2440, 2445. Yeah, 2440, 3500 kV. So, is it going to be fast? No. Is it going to do jumps? No. But what will it do? It will run over weeds. It will roll over if inverted. We'll talk about that. And so that's all it's going to do. It's just going to be something different. It's not going to be screaming fast. Jet boats, they have to be moving. I'm not going to put a reverse on it, so it's going to have its share of limitations. But it's just something different. And I'll show you what my plan is. You know me, I can never leave well enough alone. Because well enough often isn't. This is the size pump I'm going to use. It's a little tiny pump. It's a 15 millimeter pump. This is injection molded plastic. Now let's talk about injection molded parts. How they're made is they take these steel blocks and they machine these steel blocks so they fit together in a puzzle that leaves a little space. And then that space gets injected with plastic. Now, these blocks, if you're buying a plastic model airplane, they're real simple. You got a top and a bottom, and boom, you mold your parts, and there's all your parts laid out, and you got the little plastic sprue with all the fingers out that hold the little parts that have just the littlest of tabs connecting them. That's injection molded plastic, but it's just a two-piece mold, really simple to make. A mold like this takes several parts. You've got to have this side, and then you got to have a part that goes in here, and then another part that goes in here at an angle, and then you got to have a part that comes down on top of this, and that's the part we're going to talk about. And then you probably have a part that goes in here too. So the part that forms this flat surface also forms, you can see the parting line. There's a little 45-degree line here, and then it's flat all along here. So this entire back surface of this curve is vertical, so this piece can pull out because it makes this edge of the internal void that gets filled with plastic that becomes this part. Look, I have a new tool. we're going to see if this works. So what you have here is the flat part of the boat, the pipe that goes up, and the tube that forms the pump. But then this edge comes straight down like this. And so the water coming in here, and here's your impeller here. The water coming in here slams right there into that wall. So what I have done here is I've cut this wall off like this, because water does not like to change directions really fast. Water's 800 times more dense than air. When water slams into this vertical wall and has to go around this 90-degree corner, why, it sucks energy. It takes energy to go around that corner. And in fact, what happens is, at any one point in this channel, the same amount of water is moving. I mean, for every drop that comes out here, there's a drop here moving. You know, it forms a column of water. Now, the column can change diameters, and then the volume per unit length changes, but that one drop that's moving replaces that one drop that's moving. So the easier it is for this drop to move, the easier it is for that drop to move. So I took this little thing, I filed the heck out of it. I have basically made it now a nice, smooth, and improved pump. And for example, here's the old inlet, here's the improved inlet. Slightly larger, thinner, more water going through it. Now the plan is this. This thing's pre-molded, and everything has to fit to the locations of these screw holes and the locations of these screw holes, because these screw holes attach to the nozzle and have to be flat up against the back of the boat. So the back of the boat has to be a perfect 90 degree. And in fact, if you can see, there's a little recess here, and I would like to be able to recess that portion of this pump body into, make the hole in the bottom of the boat that size and the shape. So precisely that size and shape. And it has to be precisely flat, and it has to be precisely 90 degrees to something else that's precisely flat. And I know this is a hand laid up hull coming, and it won't be precisely flat. It'll be flat, but it won't be precisely flat and precisely 90 degrees. It comes out of a mold. It's got to have some relief angle. So what I'm going to do, instead of just bolting this down to the hull, I'll cut a hole in the hull, and I'll make, imagine if you would, this is a piece of G10, and I'll take a piece of G10 and I'll make a bottom plate that's a little bit larger than this, and then I'll make another G10 plate that fits here that's a little bit larger than this, and then I'll glue them together at 90 degrees, and then cut a hole in the boat and glue these G10 pieces in to where they already have, the flat on the bottom that's not quite flat. But once I put this piece of G10 in, and sand it flush, it'll all be good. And the G10 will become the bottom of the hull and the transom. You guys follow what I'm saying? Do I need to draw a picture? Nah. So that's my plan. Until next time, boys and girls, jet out.